here are the solutions to review number 1. Be sure that you have tried all of these problems first, the best you can. I know without a compass it's difficult to do the constructions, but make sure you found some class time where you could do those. I try to give you some time in class to do those. All right, so here's the solutions and what everything should look like for your review number 1. So the first 3 questions refer to this diagram here. Which of the following, angle 3 and angle 7, can be what can they be classified as? Well, here's 3 and here's 7. And those are in the exact same position. One's up here, one's down here, but they're in the same position. That means they are corresponding, so that is choice B. How about 4 and 5? 4 and 5, one on each side of the transversal. They are interior because they're in between the parallel lines, so they are alternate interior angles. So that is A. And then 4 and 6. 4 and 6 are on the same side of that transversal, and they're interior in between the parallel lines, so they are same side interior angles on the same side of the transversal. So that's choice C there. All right. What is the value of the x that makes L1 parallel to L2? Remember, the lines will be parallel when the corresponding angles, these are corresponding angles, when those angles are equal. Okay, so they should be equal. So we have 8x must equal 2x plus 60. When 8x equals 2x plus 60, we're trying to find the value of x that will make them equal, and that will be when the lines are parallel. All right, so 6x, you just subtract 2x to the other side, 6x equals 60, and then divide by 6. Right, x equals 10. So what is the value of x? It would be just 10. All right, so D. What is the value of x that makes L1 parallel to L2? Now we have same side interior angles. They're on the same side of the transversal. Those are supplementary, so they add up to 180. So you're going to combine them. 8x and 2x is 10x. Negative 14 plus 54 is 40. And again, they add up to 180. Same side interior angles add up to 180. So we're going to subtract 40 to the other side, and we get 140, and then divide by 10. And x is going to be 14, so that is choice A. All right. Hopefully we did well on those. What types of concurrent constructions are needed to find the incenter of a triangle? The incenter is found by making 3 angle bisectors. So that's going to be right here, the intersection of the lines drawn to bisect each vertex of the triangle. The vertex is the point where they come together, right? That's where the angle is. So if you bisect that vertex, you're bisecting the angle essentially, and that's going to make, if you do that 3 times for all 3 angles, all 3 vertices, that's going to create the incenter. That's the definition of incenter. All right. Number 7, if ABD is 70, so that angle, that big angle is 70. That's these 2 little angles put together. EBD, so just this little angle here, is 40. All right, well, if the big angle is 70, and then just a piece of it is 40, what is ABE? ABE is what's left over. So what's this piece right here? Well, again, the whole thing's 70. This is 40, so what's left over? 70 minus 40 is going to give me 30, and that's our subtraction postulate. So 30 degrees there. Use the information in the figure to state what conclusions you can make. Well, I could tell just by looking at this, I have an isosceles triangle. I have 2 equal sides, 8 and 8. That's given. If I have 2 equal sides, the opposite angles must be equal. So if this is 70, this angle must be 70. So the measure of angle R is 70 degrees. I know that. All right, what else do I know? Well, I know that because I have 2 angles that are 70, that's 140, right? 70 times 2 is 140. 140, not 40. 140, right? What do the 3 angles of a triangle add up to? Well, the 3 angles of a triangle add up to 180. So what's this last angle? This must be 40. 180 minus 140 gives me 40. So that last angle, angle P, measure of angle P is 40 degrees. Okay? So that's what we can, those are the only conclusions we can make. We can't say for sure that QR is anything. If you put QR equals 8, that is not correct. In fact, it's wrong. If it's isosceles and two sides are equal and two angles are equal, if that third angle is not the same, which it's not, right, then the third side would not be the same. This side has to be smaller than 8, something smaller than 8. So that could be a conclusion. QR is less than 8. We don't know what it is, but we know it's less than 8. So that would be an excellent conclusion to make. All right, so if we have parallel, right, they're saying this is parallel, these are parallel. If you put little arrows, see how it's like a single arrow and a single arrow, that means parallel. That means these are parallel. I put a double arrow and a double arrow, that means those are parallel. And that's given right here. Okay, so they're basically telling us we have a parallelogram. All right, I'm going to erase that just so it doesn't get ugly. DEH, that's the exterior angle, is 128. Remember, the exterior with the interior, that is a linear pair. Look at that. You got 180 right here. So 180 minus 128 is 52. All right. So this angle inside here, this angle right here is 52. Parallelograms have opposite sides equal, so this must also be 52. All right. And if these are 52, the consecutive angles of a parallelogram are supplementary. So this must be 180 minus 52. All right, so that's going to be 128, which is originally what this was. So angle 2 is 52, angle 3 is 128, and angle 1 is 128. Now, how do I know I'm right? Well, if you add them all up, you should get 360. Okay, so 256 and 52, and then another 52 gives me 360. All right? And then number 10, and then we'll do our constructions. Number 10, two parallel lines cut by a transversal. AFG, that's this guy right here, and FGD, and that guy right there. See this one and this one? They are alternate interior angles. Look for a Z. Boom, boom, boom. See that Z? Boom, boom, boom. Okay? You got that Z, and then the angles in the Z. Those are always alternate interior, and they are always equal. So we're just going to say 2x plus 10 equals x plus 20. And then move the x over, move the 10 over, x equals 10. And that would be it. X equals 10. Okay, so a lot of review stuff here, not much new. Now the constructions you're going to need to be able to do. So constructing an equilateral triangle, how are we going to do that? We're going to start by taking our compass, and we're going to get the distance from A to B. Okay, so there it is. So see, boom, no matter where I move my compass, I can put it down on my paper, I can put it up, throw it up in the air and catch it or whatever, but no matter what, I put it back, and there it is. You can see the distance between A and B. So I'm not going to move that. I'm going to keep it exactly the way it is because I want to make an equilateral triangle. All right, so I'm going to keep it there. From point A, I'm going to rotate. Oh, did I move it? I wonder if I just moved it by mistake. Let me make sure I didn't move it. Nope, I didn't. Okay, we're good. We're gonna make arc right there, and then I moved it. See, undo. Oh, we don't want to undo. What are we doing here? I thought it would undo that. All right, let's try that again. Boom. All right, now take your compass from point B. And do the same thing. There we go. And because I use the same compass setting for all three sides, I know that this right here, this point, is the same distance to B as it is to A, and it's the same distance that it is from A to B because I use that same distance to begin with. So I'm going to take my straight edge. All right, rotate a little bit here. take my straight edge, and I'm going to connect A to B. All right, connect A to B, and then again with my straight edge, I'm going to connect from B to C. So I have C, and that is my equilateral triangle right there. You got to have the arcs to show that you measured. If you don't have the arcs, you don't have a construction. Okay. Locate the midpoint. The midpoint is going to be found on the perpendicular bisector. So they might say construct the perpendicular bisector, whatever. So that's going to be done with the compass again. So we're going to put our compass point on A. We open it up more than halfway. As long as it's more than halfway, you're okay. We're going to do a half a circle. And then from B, we're going to do a half a circle again. And the intersection points right there, I have two intersection points, one right there and one right there of my arcs. If I line those up, I actually get the perpendicular bisector. So it's actually more than what I need in this problem. But if I do the perpendicular bisector, I'm hitting the midpoint. The perpendicular bisector goes through the midpoint. Why? Because it's bisecting. It's cutting it in half. If it's cutting it in half, it's got to go right through the middle, so it's got to go through the midpoint. Okay, so perpendicular bisector is how you're going to get the midpoint. Line perpendicular through point P. So for this one, put your compass point on P. Open up your compass. It doesn't matter how far. You're going to need an arc on each side of P, on both sides of P. All right. So I know that, it doesn't matter where, but I know that this point is the same distance to P as this point is. So, well, let's call this, we can call it anything. We can call it A, we call that B. So AP is the same distance as BP, right? Because I use the exact same compass setting. Now, take your compass and swing an arc from point P, I'm sorry, that's wrong. From point A, from point A. I'm going to open up the compass a little bit more. All right. Swing an arc. And then from point B, swing an intersecting arc. See that? So there's a point right there. This point right here should line up with P. And we're going to do the same thing below on the other side of the line. I'm going to rotate it around. Notice I have not changed my compass setting at this point. So from point A, we're going to swing an arc. And then from point B, we're going to swing an arc. And there's another point on the opposite side of P. But if you take your straight edge, I might have to extend my straight edge a little bit. I think I can do that. There's a way to do that. I just don't know. Oh, there it is. There we go. Okay, so right there. So I lined up those points and connect, and there we go. There's our perpendicular. See how it's perfectly, it makes right angles. That means it's perpendicular through point P. All right. Perpendicular through point P. Same thing now, except this time you got to hit the line twice. We're going to go to point P, and we're going to open up our compass. Open up our compass. We got to make sure we hit the line twice. Okay, so there we go. I hit the line twice. I have one point right here, and I have one point right here. We'll call that A, and we'll call that B. So you still have A and B. Point P doesn't have to be on the line. Doesn't matter. Off the line, on the line, doesn't matter. It's the exact same construction. It's the exact same construction as number 13. AP is the same distance to BP. Did it matter that P was on the line? No. I still have 2 points that are equidistant to P, the same distance to P. So now from A and B, make arcs up here. There we go. And I get point C, call it whatever you want, point C, and then we'll connect P to C. We'll connect P to C. There we go. And there it is. There's our perpendicular line through point P that's off the line, but it's the exact same construction as really number 13. And then we're going to do the in-center, construct the in-center. The in-center is 3 angle bisectors. You're getting a lot of practice here. 3 angle bisectors. 3 angle bisectors. All right, so let's do that. I'm going to do one in each color. Okay, so I'm going to start with A. Open up my compass. Again, to do the angle bisector, I want to change colors here. Let's go to blue. Okay. To do the angle bisector, we got to hit, so we're bisecting this angle A right here, so I got to hit these 2 rays twice. All right, and from there, from those points, let me mark those 2 points. From that point and that point, make it blue. From that point and that point, okay, we're going to swing arcs. I'm just going to put it outside the triangle so it's less confusing. Open up my compass so I go outside the triangle, less confusing. Swing an arc out here, and then from the other point you swing an arc again. See that? So where they intersect, boom, and then I would draw with my straight edge. Rotate it more. There we go. With my straight edge, I will connect. You could probably go faster than I can with this thing. There we go. So there's 1 angle bisector. I bisected angle A. Now I got to bisect angle B. All right, so I'm going to switch to green while I do that. Everything switches to green. I'm going to make a smaller. We don't need such a big one to start. I'm going to go even smaller. Alright, and oh, I thought we did green. What happened to green? Green. Green, there we go. Alright. That's just a coincidence that it hit that one right there. We don't care about that. Alright, so there's 1 point right there and 1 point right there. We're going to do the exact same thing. We're going to take this right here. We're going to open up our compass now. Open up our compass so we get, I'm going outside the triangle just so the diagram doesn't get confusing. I don't want too much intersecting inside here. So open it up and then boom. And let me get that out of the way. And from the other one, oh, did I already do that? No. Boom, right there. Okay, off a little bit. Off a little bit, but that's okay. Right there, should it be. Erase that little one right there, okay? Alright, and then we'll take our straight edge and connect. We're almost done here, guys. I know it's getting long, but it takes me time. If you know what you're doing, then you're good to go. Alright. Close enough. Alright. So there's another angle bisector, so we cut that angle in half, and then we're going to switch to red, and we're going to do angle C. So we're going to close this up a little bit. We're going to go to C. We're going to rotate around, close it up even more. I thought we said red. We piece of that red. Alright, there's our arc there. We're going to go to that point and we're going to open it up, go outside the circle. We're going to do an arc down here, and then we're going to go to the other point and we're going to do an arc. Oh no, I opened it up though. So we got to try that again. Got to make sure you don't change that. Am I on there? Close enough. Close enough. Okay. And then from here, right there. There we go. And boom. Right there. So now straighten out that ruler and we're going to draw this last angle bisector here. Sort of, kind of, the best I can. I can't get it to snap right on there, but we're going to do the best we can here. See, it's off just a little bit to the left. I couldn't get the ruler to snap right on where it was supposed to be. But as you could see, where do the red, blue, and green all intersect? They intersect at one point, and that's called a point of concurrency. More specifically, it's called the in-center. Because it was created by three angle bisectors, angle bisector, angle bisector, angle bisector, all three angle bisectors intersect at one point called the in-center. And that is a point of concurrency. When three or more lines come together, it's a point of concurrency. I will see you in class for the quiz tomorrow. Hope you're ready. I think you are.